This time we have a chemical name and we have to come up with the chemical formula. And these are transition metals. We know that right away. We don't even have to look on the periodic table because anytime you see Roman numerals, that indicates the charge of a transition metal. Okay. If you're trying to find the symbol for chromium, you know right away, I gotta look in the D block to find chromium. And I find chromium's a Cr and has 2 I's or +2. Remember, the person that's first is a cation, so it's a positive charge. So any charge on a transition metal is going to be the positive one. Don't just write 2, write +2. And just remember, he's in front, so he's positive. We leave the negatives to the end. We always start with a positive. So chromium's a +2. Oxide is for oxygen, which is an O, and its charge is -2 when you look on group 16 on the periodic table. Same thing we do before. Is this a basic or a crisscross? Well, these charges are the same absolute value, which means it's a basic ship. So we can just smush them together, CrO. Okay, lead is Pb. 4, again, is for the charge, not the number of atoms. Remember, the Roman numerals are always the charge, and they're always positive. Sulfide is sulfur. He's in group 16, so he's a -2. Is this a basic or a crisscross? My absolute values are different, so it can't be basic. We have to crisscross here. So the 4 from lead goes down to be 4 atoms of sulfur, because it's the absolute value. -2 from the sulfur becomes 2 and goes down there with the lead. So you switch their places and you write the absolute value, because the bottom is the number of atoms and the top is the charge. Now when we rewrite this, we rewrite it without the charges, Pb2S4. So that is my formula, Pb2S4. Oh, but wait, this is in its simplest form. Okay, so remember when we're doing ionics, we always simplify. So both of these can be divided by 2, and so we end up with Pb S2. So that's our official formula.